So let's welcome Bob to the floor.
Thank you. All right, I want to start with the question, show of hands, who actually has a printer in your business right now? That's beautiful. Now, of those, how many of you, those printers are printers that have a value greater than $10,000 to replace? Most of them. Okay, that gives me an idea of some of what we're talking toward here. All right, so email. All right, maybe that's not a real email, maybe that's a fictional email. But I've seen emails darn close to this. Important words here: executive strategy retreat, salesperson from something systems, competitor has ordered one. They've got approval, 850,000 space bucks. Approved, drop everything, let's do it. Party time, right? We've got management approval, we're ready to go, we're going to move into the 21st century finally, everything's great. Maybe not. And some of you guys that have brought printers in, I'll bet some of you are kind of thinking, yeah, we could have done it a little bit better. Most companies could. All too often it ends like this, with phrases like, it never made parts like we expected. It's too slow. Too much maintenance costs. Materials too expensive, especially if you're in metals. Setup takes too long. Yeah. The Asha guy just chewed me out. Or my personal favorite, the fire marshal. If you're working in metals, yeah, you're probably going to be talking to him at some point, hopefully before something happens rather than after. Why? My argument is that it's mostly hype and glitz. And that's what we have to put away. Gartner research, the hype curve. How many people know what this is? Okay, about 40%. Gartner research came up with this idea that any technology, it starts down here at invention, it gets triggered. You get a lot of press, you get a lot of people talking about good things, and after a while you reach the point that, by golly, we're going to cure cancer. And we're going to do it on the moon. Okay, and then reality starts setting in. Some of the early adopters, they start getting their equipment, they start finding out some of the problems, and we start getting more and more depressed. And we get down and we're disillusioned and things are hurting a little bit. And then we go about it a little more maturely and we solve our problems and we change the world. I started really actively trying to be fully knowledgeable in the world of additive in 2011. This is based in 2014. 2012, additive manufacturing, 3D printing in general, that's when it hit the peak right here. Now this is a special breakdown just for all of 3D printing. But in 2011, you notice manufacturing operations right there, right getting ready to ride the roller coaster. 3D printing for supply chain, way down here. Industrial 3D printing, which, by the way, they finally just destroyed as a category because manufacturing operations is the same thing. Prototyping's very happy, way out here. Okay, we're good. All right, this is July of, wow, that didn't come out very well. This is July of 2018. 3D printing and manufacturing is down here. So the last 5 years, I've spent a lot of time in meetings with folks that are trying to figure out what's really going on. And 3D printing for supply chain, yeah, we're getting ready. We're kind of in the roller coaster for this supply chain idea. It's a great idea, but prototyping, not even on there anymore. Service bureaus, all out there. Since 2012, I've decommissioned 3 printers. Okay, that's 7 years ago. How often do you decommission that much of new equipment? Not very much. One of those was kind of an overhyped government grant that, well, it would have worked a lot better if they'd spent about half as much money on a different printer. I've worked on a consulting project for a very large company where they said, our VP told us this project would be done with 3D printing. We need to make sure we do it the right way. That turned out to be a success. They worked it through, they figured it out, they had a real business case for using it. But there was a lot of fearfulness in the process of, have we made a big, gargantuan mistake? I've left $20,000 worth of consulting fees on the table for another company when I was sitting in the conference and realizing this is the wrong tree for them. And I decided to do the honest thing and tell them, guys, no, you need to stop this and do it a conventional way. They did. I think I built some trust there, but it was still a little bit painful. And I've upgraded my own printer twice. This is a dynamic, evolving field. So how do we avoid this and instead build a cool new bridge to profit? And by the way, this is a really cool bridge. Those are robots actually welding on metal to build a bridge. This is an artist concept. That's not what they actually did. That's what they actually built. That is a metal bridge that they built, and I'm presuming that they used the crane to move it over. But if you look at some of the curves on it, it's a very interesting artwork and a very interesting bridge, and it will probably last a very long time if they use the right metals. What's a 3D printer? Well, first, it is not some magical fabrication device where you're on the Enterprise and you can make some kid a toy. Well, you can make toys, but they don't just magically appear in 30 seconds. And no, it's not a replicator like they have on Star Trek. Yeah, we can do food, we can print food, but it's not going to magically appear quickly. And by the way, it's interesting, you probably can't see it on the scale here. That's 2014, right when we were at the top of our expectations. Haven't heard a lot about that. We're not seeing a lot of food printers out there. This is what it is. It's a tool in your toolbox. It's not replacing anything. I would argue that it is the best, most flexible tool in your toolbox, but that's what it is. I would even argue that it's probably, in reality, a whole drawer, because we've got a lot of different technologies. If you look at the handout, we've got a great table that shows the various classes of manufacturing or of additive manufacturing. Very much worth looking at. Kind of the same table, although I kind of expand on it a little bit. The table's much prettier, better graphics. There was no way I was going to fit it on this screen. But I actually tried several ways to create a similar table. But if you go through it, okay, we've got vat polymerization, material extrusion, material jetting, blah, 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 all the way down. These are all interesting technologies that have their own place. Powder bed fusion. That's where we're talking about powder. We're using some type of energy source in this bed of powder to build something, either in plastic or in metal. That's what those parts are over there. That's what has been heavily adopted as the metal technology. There are other metal technologies out there. That's the one that is probably 95% of the business right now. Notice those numbers I've got there. I circled them. What are they? I subcategorize these because each of these has its own different ways of running. So if you add it all up, there are 35 different technologies out there. 35. Which one is right for you? Well, it depends on what you're doing, but there's a lot of flexibility out there. An awful lot. How do you figure out which one? Well, I will tell you, 90% of the information out there, this is kind of, I did a quick add up in my email inbox of all the various stuff that's flooded in. 90% of what I've seen out there actually is coming from a sales organization. It's marketing. And whether you like it or not, the guys marketing to you, they're not trying to sell some competing technology. They would be stupid to. So you really, really have to try to figure out, how do I get diverse information? In the financial management world, what they tell you to do is use a fee-for-service advisor, someone who is paid based on results and advice and time, not based on how many machines they sell. And yes, we have at least one salesperson in this organization. I'm sorry, but or in this room rather, I'm sorry. You're doing your job. You're doing your job very well. But everyone needs to understand you'll get fired if you start talking about your competitors' technology. This is, by the way, where I do a small plug for myself. That is part of what I do, and we'll talk about that a little bit. What are you going to do with it? This is a business decision. You're buying an expensive asset. It's a business decision. It's not the glitz. It's not the hype. Yes, it helps to have the emotional side of the decision behind you in the organization, but that's not what you want to do. What are you going to do with it? And more importantly, how is that going to make money for your organization? That is the key question you need to ask. At the same time, are there hidden values? Are there things we can do with it other than that core project? I've seen printers purchased for one reason and then heavily used for a completely different reason when someone else in the organization figures out, hey, wait a minute, I can do this and solve this problem. How much will it cost to buy? What are your startup costs? Are there any hidden costs there? I'll bet there are. There's a lot of complexity to this new process. How about the operating costs? Seems pretty easy, material, labor, that's it, right? I'm going to just say no, and we'll talk about that. So let's talk about cost first. Now, cost is something that every business person has to pay attention to. Some pay too much attention to it, some pay not enough attention to it. Either one has a way of going out of business, so you want to hit the right balance on it. It's a little bit depressing. I didn't even want to talk about cost, but we have to. I had it lower on the list of things on the previous slide, but I'm going to talk about it first. The reason being that it's depressing. Donald Sutherland got it right in the movie I was watching this weekend. Let's not get too down on it, but we got to talk about it. And to talk about it now, then we're going to talk about the fun stuff. Your initial cost. Machine capital shipping, installation costs. Yeah, obvious. Anyone who's run a manufacturing plant knows this. Wow, we got three at once. File prep software, computer, okay. You have to prep the model. Most of the time with the machine, the software is getting included. Maybe the computer isn't, maybe it is, but it's one of those things I've seen on installations where someone says, wait, I've got to get that too. The software, if you do have to pay for it, sometimes we're talking $20,000 or $30,000 for a license. Post-processing, you've got to do something when it comes off. You got to remove the supports. If you're doing a metal powder bed process, DMLS, you might be looking at a machine shop. You probably are looking at least a bandsaw, if not a wire EDM, to remove them from the build plate. If you're doing plastics, it's guaranteed you're going to have solvents in post-processing. Facilities, utilities, okay? Most of these bigger machines require three-phase. Not a big deal if you're that kind of operation, but if you're bringing it into an office space, that's a big deal. Compressed air, kind of the same issue. And by the way, all of that power on that three-phase, those kilowatts of power, that energy is going somewhere. You better make sure you've got an air conditioning system that can haul the heat out of the room. Okay, powders explode. Metal powders, especially aluminums, titaniums, you're going to have to think about this. Remember what I said, you're going to talk to the fire marshal? Yeah, you're probably going to talk to the fire marshal. Set up for cleanliness. The plastic process in particular, SLS, the room it's in after about a week is invariably coated with this white powder. No matter how much you try to clean, there it is. So you're going to have to deal with that somehow, and you may wind up building a separate room. Support gases. These things work under atmospheres for the higher end machines. You're going to have to figure out where you're going to get your nitrogen, and if you're running a oxidizing metal, probably argon. Training and a learning curve for your operators. Yeah, they're going to have to learn to do this. Even if you've got some experience, you're going to have to learn your machine. QC system, it's not just send it to the lab. Yes, You can check all the geometry on a CMM, but you're also going to have to worry about when we oriented it in the bed, did we orient it this way or did we orient it this way? Because it changes and they're not all the same. So traditional SBC techniques don't necessarily work. At the same time, how you orient it in your processes actually affect your material properties. So you might be sending coupons for testing of properties after every single build. Initial stock, some of these materials are expensive and the build gets scary really fast. Build plates, that build plate, we're building it on a build plate. You need more than one because you might be sending that build plate to get the part off out of a machine shop because they're using wire EDM to pull it off. Your machine sits out, no, you're gonna have 20 build plates. They're not cheap. Operating costs. Utilities, yeah, I already mentioned that. Preventative maintenance repairs. I hate to tell you this, we're getting better and better and better. Much, much better than it was 10 years ago. But these machines are not necessarily designed like that Cincinnati that you've been running for 30 years. File prep software, hey, that license, it was $20,000. 1 year and 1 day later, you better make sure that you don't have it popping up, license expired. Again, they're not cheap. It's like buying a CAD seat. Post-processing. Time for them, support materials, same thing. If it's a plastic, you got solvents, you got other materials. Facility, the cleanliness thing, again. Support gases, yeah, if you're buying argon, yeah, that's not cheap. If it's just nitrogen, okay, if you're getting it in a dewar, you're still spending money. Nitrogen, the good news is you can also buy a generator. Did you buy that generator when you were buying your capital equipment? Labor, need operators with specialized skills. Once you get them trained, you're gonna really not want them to leave. Calibration and accuracy. Again, are you running test coupons and testing the test coupons on every single run? If you're doing aerospace work or medical, you probably are. Raw material, shelf life, oops, shelf life. Yeah, I've actually tried to do biological stuff where I went to a company that was a sub-supplier for us and we wanted something that was biocompatible. Well, there was a material for their printer that would go biocompatible. They quoted it, everything was good. And then someone looked at it and realized that all of the material they had was expired. They didn't run it very often, so they were gonna charge us. They came back and said, we won't do it unless you pay to buy an entire cartridge of this material. And it quadrupled the cost of the job. We literally had to just find a new direction. Raw material, can't always recycle it, especially the SLS material. Yeah, you got this big tank of powder. Big tank of powder. You think you can just sieve it, reuse it. Not 100% because some of the processing and the heating causes problems. Metal isn't too bad on that. You have to sieve it, but for the most part, you're okay. Wear components, like those build plates, well, after we wire EDM off, we're gonna grind it flat again. Yeah, you're grinding the thing that you build on. Yeah, you're gonna be replacing it. So we're done with the boring stuff. The negative waves are done. Let's talk about what we can do with this. Non-functional prototypes. If a picture's worth 1,000 words, a 3D part held in the hand is worth 1,000,000, absolutely. Form and fit. I have many times pulled a design part off, looked at it, wow, that wall's thin. Redesign, but you get it when you get that 3D part. But it's better you do it there rather than after you spend $500 on a machine part. Assembly, space management. Got an example, I'm going to talk about that in a minute. Communication with your team, your suppliers, your management. Hey, this is what we're working on, this is what we're doing. And by the way, to the CAD operator, this edge here, this is the one I want you to put a chamfer on. Rather than trying to draw it, you can show it. Communication with your investors if you're a new product. Communication with your customers, early sales samples. Again, I'm going to talk about that in a moment. It's worth 1,000 words. Well, okay, so you've got a motorcycle. This is actually only about 4 inches long. It's a model of a motorcycle. It looks really pretty. If you're talking to the marketing guys or the styling guys, they can figure out, hey, how good does that yellow really look? And by the way, this bottle here is right where the rider's thigh is gonna go. You can figure stuff out. Or if you happen to be a surgeon, the surgeon can look at this and she can say, if this is built on the patient, this is the standard. This is what's normal. This is what I expect to see. But then we've got the radiologic one that was generated, and oh wow, there's something weird going on there. So before I get in there and cut skin and I've got this patient on the table, I can figure out what's going on. So again, that physical model, the picture works. In the medical world, they're doing a lot of that, by the way. This is the first part that I ever printed. Actually, this is the final part that came off that went into production. It's a fuel rail for a GM premium V8 engine model year 2000. And we were doing something new that we were injection molding the main sections that held the fuel injectors. Customer wanted a sample. Big, long plastic pieces. We were told 4 months to get our plastic pieces. That wasn't going to be acceptable. We got down to 2 weeks. I went to another shop. I didn't print it myself. Customer has something solid and realistic in her hands. Terry was very happy. In fact, when she accidentally had a toolbox roll off of the seat in her car in Detroit traffic right on top of it, she begged me for a second one. Geometrically correct to the point that they used it on the engine buck under the hood to protect that space and that geometry under the hood. So this literally became a non-functional part of the development process. Functional prototypes, even better. Fail early, fail often, fail forward. We've all heard it, right? Well, part of that is to do testing. We're accelerating the design cycle when we can do it quickly right there in the office. Test designs quickly, low cost, lots of iterations, functional prototypes available for those sales samples. Even better if they're sales samples. Again, in automotive, it's a big thing. They're doing a lot of intake manifolds now with SLS nylon fill, or SLS glass filled nylon. Really doing a lot of those. At the same time, in injection molding, okay, maybe you've got this complex injection mold you want to build for the housing on your hand tool. Let's see if it actually fits people's hands. Tooling. This is a big one, really big. This is one of those, we bought it for prototypes and we found out we can do cool things with it. This is lean manufacturing at your best when it's your tooling. Your tooling, you can get it quickly, easily, and you can redesign it right there in your own office. So for example, here an example, customized grippers. In this case, it was made with metal. It could also be made with plastic if you need to be more gentle. And you can replace them anytime you want. Injection molding. Yes, we're doing injection molding with printed molds. Can't do all plastics, you can't do high volume, but when you need 100 pieces, it works. Or just your check fixture or your assembly fixture. This was printed on an HP printer. It's a plastic process. They even have the color built into the printer, so you can put all of your geometry right there. It's cheap to make if it's on your own printer, so you want to replace your fixture, change it, make it better, do it. At the same time, this color, you can make it only a certain depth. So when you get wear, suddenly that red pin there turns white. Hey, wait a minute, we got wear, it's time to replace it. Okay, this is where it starts to really get interesting. Doing the things you couldn't do before, okay? If you're printing your sand molds and cores, which we can do that now, there's at least one company in northern Indiana that's making a business of just that. Okay, negative draft, overhangs, stuff that literally cannot be cast, they can do. Direct print of investment shells. Used to be you had to have your mold for your wax, you make your wax parts, somebody assembles it on a tree, then you spend a lot of time dipping it in a slurry, you make the slurry, then you can melt the wax out. then you finally have a mold to use of a ceramic for casting. Just print the investment shell. Skip all those other steps. That's happening. Part serialization in the mold. If you're printing every single mold in sand, guess what? It's easy to put those serial numbers in. It's easy to make every part different. In the injection mold world, the hard tooling world, they figured out that they can do nice curved cooling channels rather than straight lines. Mass customization, hearing aids, dental aligners. If you get a hearing aid now, it's pretty much guaranteed it's custom to your ear. That's not the way it used to be. And yeah, they're printed. Supply chain. You got a big company, hey, your engineer here prints the part in the printer that's on the far side of the country or the world. Please don't try to make production parts. Please do not try to make production parts that are conventional. You're not going to do it. It can't compete with injection molding, not on a piece price cost. But there is something you can do. Make that part that Coswell Cox can't make. Turn your engineers loose. Tell them they can do whatever they need to make the perfect part, rather than worrying about the fact that they have to have round holes because holes are made with drill bits. No, they're not anymore. They can be curved holes too. Like this, those are internal steel passages. And by the way, when I was here last year, we talked about a project we did for the nuclear engineering, or actually nuclear physics department for Notre Dame, where we did exactly this, printing some metal parts for them with curved internal passages. Okay, at the same time, there's this thing called topologic optimization. The math guys, the CAD guys have all figured out that we can use math to go from designing a part that's solid because we don't know it. We can identify exactly where we need the metal and create these science fiction looking parts that are just struts, and there's no wasted space. At the same time, if you're building this up out of a environment of powder, that powder, if you can recycle it correctly, isn't wasted. But if you try and machine this out of this giant billet, and by the way, there was a lot of billet material removed just to do this, you're not wasting material. It's called buy to fly. It's used heavily in aerospace because they do things like buy giant chunks of titanium and then leave most of it on their shop floor. Not anymore. This is an actual example. It's a cabin bracket for, I believe, an Airbus. They actually went to this. It was made of aluminum. It was big, bulky, clunky. They were able to make it out of titanium, cut the weight, I think, by like 70%. Titanium, too, by the way. Another example, basic bracket looks like this. Even your marketing guys love it. It looks sci-fi. Brake pedals. Brake pedals look cooler. Actually, I think those are probably clutch pedals. Or maybe just do your whole motorcycle. Or maybe you do mesh lightweighting, and so you've got the entire interior section is a grid. You're not going to do that with any conventional techniques. Someone picks this part up, thinks it's heavy, or thinks it's going to be heavy. Wow, it's light. What'd you do? Make it out of unobtainium? No, just made it hollow. Surfaces can be organic in shape. This is actually a part that I picked up at a trade show. All right, it's a bottle opener. It's a bottle opener made out of Inconel. And if you look at the size of that thing, those wires are tiny, absolutely tiny. They're solid, they're hard. Okay, if I needed this for a functional purpose, this would be the only way I could make it. It's really a cool part and a fun part. What is interesting is also it's made from a DMLS type of process where they learned to optimize some things, and using technology, similar stuff, just different from what Atlas is offering. This was printing free-floating in the powder bed. It was not attached to a build plate at all. That's new in the world of DMLS. And by the way, they're designing their machine to be a true production machine. They just said, nope, we're not doing prototypes. We're doing production. It's the only reason they're doing it. And John, I'm sorry, I'm at least not telling their name. But cool parts. Again, it's Inconel. Try doing that in Inconel with any traditional process. Could have done it from titanium too. And we can also go really small. Let me point out to you the holes in that, those window holes. They're pretty small compared to Abe Lincoln's head. This was printed in stainless steel. That's not going to be easy to make. Now, this is a real close-up. You can see I'm really picking up on the surface finish and everything else, but they're reaching the point that the surface finish and the details are that fine. Also, we can embed stuff. Some technologies it works great, some technologies it doesn't work at all. These guys are doing metal, and they have made a real business of being able to embed electronics inside their device. So you could put whatever electronic device you want, and in this case, they're plugging their USB in. Or maybe you want to combine different materials. In this case, they're combining aluminum and copper, which is kind of a no-no. You can't weld them. They corrode a lot, but using their process, they can make parts with some really interesting materials, sandwiching it together. Some closing tips, and yeah, I think I'm over on time, sorry. Recognize that this technology is very powerful. There's a lot to it, and it's changing, but it doesn't replace what you already have. Think about how it adds to what you've got. It's the wild, wild west out there. Do your research. Everyone's trying to sell something. Some of them are selling snake oil. I've worked with some of those. It wasn't funny. Make a careful business decision based on a planned use case and calculate your costs. Don't follow the glitz. I think you know that, but I found it's hard. Really mature engineers and engineering managers have had difficulty with this one. Remember that making parts is one of the hardest ways to make money in this business. It's the manufacturers and the suppliers that make money in this business. The service bureaus, it seems expensive as all get out what they get. They're really not making a lot of margin. So when you're doing this, if you're going to try and make parts, you need to make the parts that no one else is making so that you can include a substantial bonus in the pricing, because you're going to need it. The real trick, making the parts no one else makes. Also, when you bring this in, the startup is going to be slow. Please be kind to your operators and technicians, because I can guarantee the first part, actually the first build will probably be fine because it's set and pat. The first time they try and do anything new and different that they weren't given, yeah, there's going to be problems. They've got to learn. There's a learning curve. Final slide, do your research. Do a lot of research. Google's really good. Just pay attention to what website you're actually going to. If it immediately takes you to the Stratasys or 3D Systems website, it's marketing, okay? That's all it is. Most of these seminars, you get invited to all of these things. CATI does a huge number of them in this area. It's marketing. You're going to be routed down a channel in order to buy their equipment. TCT Magazine's actually pretty good, especially for metals. Rapid E-News. Do the Google search. You can get there. Multibriefs.net, then it's about 200 more characters, so I didn't tell you that down. Additive metal manufacturing. If you're looking at metal, these guys have some interesting things to read on occasion. AdditiveMet.com. Go to a show. Always go to a show. CATS, whatever, that works. But more importantly, if anyone wants to pay me to get on an airliner and go to Formnext in November, I'm up for it. I will go. I've never been able to go, but from everything I know, it's remarkable. In the US, the key one is Rapid. They now call it Rapid plus TCT. Yeah, it's the same TCT. Marketing. But it's in Anaheim this year, or next year in April. Unfortunately, this past year was its rotation, or this year rather, was the rotation through Detroit. Next year, they will rotate McCormick Place in 2021. So a little bit farther next year, but really worth it. If you're looking at investing a lot of money and you can wait until April to make your decision, I highly recommend that you go out to this program. The local makers fairs. We have a tendency to look down our noses at these $500, $1,000 printers. It's amazing how much creativity and energy there is in that market. Go in, yeah, they don't understand everything you need, but you can learn a lot from them. And by the way, the basic principles of layering and support and how do you design and how do you make things work and how do you have to tinker with the machine to get it to do right, you can learn a lot there. $1,000 for a basic rep wrap machine, $500 sometimes. Set someone in your organization who likes to tinker. It's a great way to really start learning your lessons early. Always phone a friend. Yeah, I'm plugging myself, but there are other consultants out there. You don't have to call me. There's plenty of other consultants out there. Find someone who's going out and go through this question. How are you going to use it? What are you going to do? If you bring me in, the first thing I'm going to do is I'm going to get through what is it that's special about this that you really need to do additive. And as I've already told you, I will tell you whether it's a good decision or not. Phone number information. I'm done. I think I'm way